Number 41, nitrogen and oxygen react at high temperatures. And then we have letter F. What will happen to the concentrations of N2, O2, and NO at equilibrium if the temperature of the system is increased? Okay, so now we're talking about temperature. So we finally discussed this delta H, okay? So the delta H was just chilling in this balanced equation. We don't care about this delta H until they start changing the temperatures. Now, the only thing that you have to do is basically we don't care about the number. What we care about is where the heat is lying. And that just determines on, what delta H value this is. Now, they told us this was a 181. All I care about is that this is a positive 181 and not a negative. Since this is positive, this is classified as an endothermic reaction. And remember, when we did enthalpy, endothermic reactions are all about absorbing heat, not releasing. Releasing is exothermic. So if you're absorbing the heat, what side are we going to put the heat on? If it's endothermic, your heat is always going to be on the left-hand side. So I'm just going to put plus heat. I will maybe just box this in just to make it even more apparent. And because I do that, I could care less about this value anymore. So I don't look at that anymore. Now I have all the necessary information I need. So they told us that the temperature was increased. So here's the Chateliers principle information that we need. If you increase the temperature, right, it's going to get hot and hotter, and it's going to get way too hot, right? And think about it on a summer day or a really, 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 muggy, high humidity summer day in which it's just, you'd much rather be inside, right? I would much rather be inside. So when it's too hot, I like to go away from the heat. And that's what chemical equilibria do as well. So when it's too hot, you shift away from the heat, literally, the word heat. Since the heat is here, you would want to shift away from the heat. You would not want to shift towards the heat. You want to get away. So there is your shift. And that's all we need. Now we can just say what's happening with the concentrations just by this arrow. If you're going this way, you're going to make more of your products and less of your reactants. So the N2 will decrease, the O2 will drop because these are both reactants, and this we will increase. And that is basically your answer. So concentration of N2 will decrease, concentration of O2 would also decrease, but then the concentration of NO would increase, and that is your final answer. Okay, so I think we have one more part in this question and then we're done. This was an epic journey. So hang tight for letter G, and I'll see you then. All right? Okay, see you in a few. Bye-bye.